Hello, thanks for stopping by. Sorry I haven't been turning out videos lately, but this hot weather really gets me down. I do not handle heat well, and where I'm living right now isn't air conditioning, and just haven't been in the mood. Just don't have the energy to do it. But it's cooling down now, so hopefully I'll be able to get back to somewhat, more normal videos and start getting some of those other projects done. I just wanted to do a quick one here and show you this. One piece of equipment that I didn't have was a good audio generator, and I was looking, and I picked this up off eBay for $14.95 plus shipping. The seller said, it didn't work. All it was putting out was 60 cycle noise out of the outputs. And as far as that part of it's concerned, the only thing that was really wrong with it is it just been sitting around so long that all the electrolytics dried up in it. I put it on my Variac and took and brought it up slow, like held it at 20 volts for a while or whatever, to take and start reforming the capacitors, and it started putting out signal. They're not clean. I mean, it has to be recapped. But that was the major problem. Just sat around so long that everything was dried up. But when I was studying the things or whatever, let's take a look here. This is the schematic for it. Left-hand side there is a sine wave generator. And then at the top you have the square wave circuit and power supply at the bottom. Now if we break it down and look a little closer at the different sections, the sine wave uses what they call a bridge T oscillator to set the frequency. You're changing resistances as you're changing your bands, and it's just an RC circuit. And there you see where I have labeled feedback. That's the classic, like the Hewlett-Packard uses. It's a 3-watt, 120-volt bulb in the feedback circuit to keep the gain of the circuit right around 1, where it's the steadiest, and you get the lowest distortion when it's like that. That CB6 is your oscillator tube, and 6 CL6s are a buffer and an amplifier tubes. Then on the other side, you have this is what puts out the square wave. The 6 AGW, the two halves of that, the left half is a input buffer, the right half's an output buffer and amplifier or whatever, and the 12AT7 is a Schmidt trigger circuit. It takes a sine wave and converts it into a square wave, which all works very good. So, at initial looks, it looks like a pretty standard circuit until you take and start looking closer. Let's go back and look at those the 6CL6 tubes. If you look there, the left-hand tube, the grid voltage is 100 volts. Now, usually we're used to seeing grid voltages like -3 volts or something like that. The grid voltage here is 100. The cathode voltage is 104. On the right-hand tube, the grid voltage is 147. The cathode voltage is 150. Now, if you take and think about your net or whatever, you're still looking at, -4 on the left-hand side, -3 on the left-hand side, because your grid voltage is actually measured between the grid and the cathode. but the high voltages there is how they're trying to keep the. Okay, let's try this again. They're taking the signal off of the cathode to keep from loading down the oscillator using, a cathode follower circuit like that, and they're keeping the voltages up to keep the output signal as strong as they can take and get it. One side effect of this now, if we take and go and look at our power supply. Okay, this is the power supply. The main high voltage supply there is a full wave voltage doubler, taking 117 volts and boosting it up to 295 volts. Interesting thing about that is these are what they're using for fuses. They're like little miniature cartridge fuses. As near as I can tell, they're only 150 milliamp fuses. They were made back in the early 50s, I guess back when the silicone rectifiers were first starting to come out. There was a company that was putting them out like this. They're little ceramics and snap into, looks like a standard fuse holder. But I thought that was, really strange. I never saw fuses like that before in a high voltage fuse. But now getting back to the power supply, if we take a look at the filament circuit, neither side of the filament circuit goes to ground. One side of the filament goes to the, one side of the tubes. The other one goes to the other side of the tubes. So, they're isolated from ground. And they're also, if you take and look there, that where it says going to plate of V3, that's where the 295 volts is. So they're bringing the 295 volts back through that voltage divider, and the filaments actually are at 88 volts DC. There's still the 6.3 across them for the heater, but they're held at 88 since the cathodes are being held at 150, so you don't have a 150 volt drop between the cathode and the filament to take and try to keep them from shorting. There again, I've never seen a circuit where they're holding, the filaments are at close to 100 volts above ground. It's a nice unit. It's a clean unit. Here's a picture of the top of it. No dust or anything at all inside. Extremely clean. And here's a picture of the bottom. Another little thing, because everything is, including the filaments, are at high voltage. All the wiring in the bottom has some kind of insulation on it, either insulation or spaghetti. Even like the little, jumper wires across the tubes where normally you'd see just a bare wire. Everything has insulation on it, or like I said, insulation or spaghetti. And there you can see, a bunch more. You had the 3 can resistors at the top. The 1 can has 250 microfarad. Another can has 100 microfarad and a 40. The third can has 440s. And then here on the bottom you have 3 or 4 40 microfarad capacitors. In addition, you can, well filtered to make the signal as stable as possible. So this is another, and there you can see the bulb there in the lower right corner. So this is another project that will be coming up in the near future. Hopefully now it's starting to cool down. I think it's finally broken. The past couple of days now it's actually been breathable. So hope everybody else has been getting along good. Between the heat in the summer and this nonsense that's been going around with with the disease and stuff. It's been bad. I want to thank everybody for stopping by, and have a good day.